That's great. Now I don't have to yell for most of the rest of the time. Oh, I touched the HTML table. Okay, so hi everyone. I hope you all enjoyed the first week of discussion sections. Now we're not going to do that for a couple of weeks because we are going to be having you all work on a minor project, which will help you lead into working on your major project. Now, will you all remind me who all has not worked with MATLAB before? Okay, so a lot of you. Fine, that's fine. We're starting off hopefully in a way that will help you all understand how to use it and how it can be a very helpful tool for all of you. So the first thing I want to start with is this is MATLAB. All of you should know what this looks like because you turned in a homework proving that you could open it up. A few technical terms so that we are all on the same page. This right here, where you see these words, this is the editor window. So if you ever see anything specifying the editor window, that's what it's talking about. And this is where you can create scripts and functions and lines of code that kind of stay there, and you can come back to them and edit them and make comments and all of that. Okay. And then down here in the bottom, this is the command window. So I can enter in individual commands, right? So it'll give me the answer to simple equations. I can do, like, oh, sorry, you can't see that. Get this out of the way. Right, I can put in different commands in MATLAB and it'll do the various executions. Looks like it's struggling with that. Oh, yep, there applied a bunch of random lines. Okay, so the command window is where you can actually execute your scripts, right? You can type in the name of your script and it'll execute, or you can type in individual functions. You can test things, like let's say you want to test some line of math that you're working on. You can enter it in there and treat it like a calculator. Anytime that we're saying something in the command window, this is what we're talking about. Okay. So then on the side over here, on this for you, it's going to be the left side. We have a file navigator. This allows you to go to different paths on your computer to locate files. And then over here on the right, you should have a variable inspector. So for example, I did that calculation down here and it gave me the answer is equal to 2, right? Any variables that you create will show up on the side there and you can look at their values and examine them more thoroughly. Okay, so you see in the editor window, I have 3 different tabs. These are for 3 different scripts that I've created for this class to both illustrate some basic MATLAB stuff and also help you, give you a jump start on the homework for this week and next week. Okay, so the first thing, I like to start all of my MATLAB scripts a little preamble where I clear everything. I close all the figures that are open. That's what this line does. I clear the command prompt so there's no extra garbage down there. And then I clear all variables, right? So if I go ahead and run this, I ran the whole thing. So if I go ahead and run just this section right here with this run section up above, then you'll see that I cleared the variable window, cleared the command prompt, and I closed that figure. Okay. So the next most helpful thing for you all to know is that if you come across a function in MATLAB that you don't know what it does, you can type help and then space and then that function name, and it will bring up in the command window a whole long documentation about how to use that function. All right, so usually the one up at the top has the most easy detail. So it says plot xy, plots the vector x versus the vector y, or y versus x. All right. This is probably, if you have a question about what a function does, that's probably going to be your first step to figuring it out, is to say help in that function. If that doesn't work, then you just say, you go to Google and you say MATLAB, that function name. MATLAB is an incredibly well documented language. There will be examples on how to use it. There will be people who've had trouble with it and ask questions. All right, so pretty much anything you want to try and do, especially for beginner MATLAB, someone's written some documentation to teach you how to do it. Okay. So the next thing is we'll be working with a lot of vectors in this class, right? Vectors, arrays, lists, different languages call them. Yeah.
How do you differentiate those sections? Is that just between the double parentheses?
Mm-hmm. Yep. Yeah, so this double percent, so a percent sign is a comment. A double percent makes a section. So vectors are what store things like, for example, you have a bunch of x values, you store them in a vector, a bunch of y values store in a vector. A lot of you should have some sort of experience with linear algebra and then understanding what vectors are. Okay. So for example, here I'm going to create a vector that has the numbers between 1 and 10. Right, and so what this syntax here is going to do is it's going to create a vector that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then in this for loop, I'm going to go ahead and print it. So I'm going to say for every value in that vector, we're going to go ahead and print it out, and then we're going to print a new line character. So let's go ahead and see that. So then if we go look in our console window, we can see, look, we printed out all the values of that vector. Okay. Now, for the purposes of your homework, you might need to create a vector that has a different step size than 1, right? And that's pretty easy to do. If you do 1 colon step size colon ending number, so start colon step size colon end, then that will make a vector that goes from start to end with a step size of whatever you specify. Right, so here I specified 0.1, right? And so we should expect this to spit out like about 100 numbers or something like that, right? And so we go from 1 to 10 by increments of 0.1. That makes sense to everybody? Okay. So a lot of learning MATLAB is just learning the specific syntax that you need to do. Okay, so the next thing is that you can do some vector operations. The first operation I have shown here is indexing. So we're going to take vector 1, and then this parentheses says we're going to take an element of vector 1, right? And MATLAB is a 1 base, so the first value in the vector has an index of 1, right? So this equation right, or this line on 31 right here should add the first element of vector 1 to the second element of vector 1, right? And so we know that the first element is a 1, the second element is a 2, so the result of this operation should be 3. Right, so let's go ahead and put in another section symbol here so we can just see that result. And look, we see the answer is 3. Okay, that makes sense. Okay, the second operation, so I'll move that in there, is going to add them, right? And so when you add 2 vectors, as long as they're the same size as each other, right, then it's going to element-wise add them together. So it should be 1 plus 1, comma, 2 plus 2, comma, 3 plus 3, and so on and so on. All right, so if we go ahead and make that a section, run it, right? We get 2, 4, 6, 8, 10, 12, right? Makes sense? Okay, I encourage all of you, we're going to send out these files. I encourage you to all try them, maybe manipulate them a little bit, see if you get different results. The next thing is 2 different types of multiplication, right? So we've got element-wise multiplication. That's what the dot multiply means. Okay, and so what that's going to do is for each element, it's going to multiply it by the corresponding element in the next matrix. Right, so it'll be 1 times 1, comma, 2 times 2, comma, 3 times 3, and so on and so on. And as we expect, that produces 1, 4, 9, 16, right? All the squares. The next thing is the more linear algebra version of matrix or vector multiplication. So you can see we have vector 1 times vector 2, and then this little apostrophe. An apostrophe in MATLAB transposes, right? So if you remember from your linear algebra, in order to multiply 2 vectors, you got to make sure that the dimensions of the vector line up correctly. So vector 1 we see is a 1 by 10, right? So 1 by 10, we got to multiply that by a 10 by 1. Does that make sense? Okay, so our output should be a single number, right? And if we look at that number, that's just the sum of all the squares, the dot product between those 2 vectors. Hopefully some of that is jogging some math class memory. The important thing is that sometimes you'll do vector multiplication when you mean to be doing element-wise multiplication. And so that's really the distinction I want to point out. Is if you mean to do every element multiplied by every other element, then you do the dot multiply. Okay, does anybody have any questions on this first part? Yeah. Yes, so if we go back up to the loop here, right, the end, you see if I highlight the for, it highlights its associated end, right? So when you do structures like a for loop or an if statement or things like that, you need to always close them with an end, okay? And MATLAB will yell at you if you don't do it. Any other questions? Okay, one last thing that I didn't show an explicit example, but I will put it in the final version. On indexing, right? So if you remember, we had vector 1, oops, not vector 11, vector 1, right? And it's this vector of 10 numbers. If I want to get the first element, I go like that, right? Oops, sorry. But let's say I want to get the first 2 elements, so the first 3 elements, right? That's called slicing. So in order to do a slice, I'm going to go ahead and do 1 through 3, for example. I'm going to get the first 3 elements. Okay, that makes sense? Okay, this might be relevant for you if, let's say, you want to make a vector and you want to change only part of it, right? So let's say I want to take vector 1 through 3 and I want to change them to all be 1s, like that. Right now, my vector, the first 3 are all 1s, and then the rest gets left alone. Okay, that is relevant for your homework assignment. Okay, I'm going to move on to the next part. On the editor window or the. Okay. And this is all Googleable very quickly. It'll be like the top hit. Okay, so how many of you looked at the homework for this week? Okay, good. The rest of you do it like immediately. Not immediately, do it after class. So if you remember from that homework, it asked you to create 2 scripts, a main script and a parameters file. So let's go ahead and look over at that parameters file. I've created one as a test example, right? And I put a lot of comments in here to explain what's going on. But if we scroll down, we just see that this on lines 11 through 14, we're just setting some values, right? So we're making x a vector, right? It's going to go between 0 and 2 pi at an increment of 0.1. We're setting amplitude equal to 1. We're setting f, which is frequency in this case, equal to 1. And we're saying phase equal to 0. All right, now all of these different parameters, they should sound pretty familiar, right? They're how you parameterize a sine function. We've got the amplitude, the phase, and the frequency. So then if I go into my main file, the purpose of this main file in your homework is to run a specific calculation. In this example, I'm just going to run an example calculation of a sine function.
One clarification, he's talking about homework 3, not homework 2.
Oh, I'm so sorry.
Don't do this for homework 2.
So sorry, got the homework messed up. Talking about next week's homework. Homework, this one's about getting introduced to MATLAB. Yeah, okay. So in homework 3, you're going to be asked to create a main file and a parameters file. The parameter file sets a bunch of parameters. So in your case, if you're doing like a fluid simulation, it's going to be like the radius of a vessel and the length of the vessel and the viscosity of a fluid and all that other junk. Here we're just running a sine example. So first I've got my same preamble as before. I'm going to close everything. I'm going to clear the command window. I'm also going to print something that tells me that I know that my script is working. All right, so we're running the main file. We're going to go down and we're going to load the settings. So in order to run this parameter file, you just treat it like a function, except it doesn't take any arguments, so you don't have to do an open close parentheses. You just say run the parameters file. Okay. And then there's a big long note here about all you need to make sure MATLAB can actually see where the parameters file is. But if you can see it over on the right or on the left here, then it should be good to go. So if we run this section, we can see over in our variable inspector that we've created a variable called amplitude, f, phase, and x. Okay, that all should make sense because that's what we set over in the parameter script. Okay, the next thing we're going to do is we're going to do our specific calculation, right? So in this case, we're going to do amplitude times sine of x times f plus phase. Okay, so then it's going to run that calculation. That's a very easy one, so it ran almost immediately. And then we're going to plot it, right? So a lot of this class, we ask you to make a plot of your output function. And it's important that you make that plot look nice, right? Both for the purposes of us understanding what you did, but also for the purposes of we use these plots in actual scientific publications. And you will likely, if you're using MATLAB in industry or any other kind of programming language, when you make plots, the presentation matters a lot. So take some time to make sure it looks nice. Okay, and there's a myriad of different ways, but the things that we want you to focus on are make sure you give it a title, make sure you label all the axes. Okay. So for example, in this one, let's just go by line. I put a print statement saying that I'm going to be plotting the results. So I can see that in the command window. I say figure 1 so that I pull up figure number 1 because that's where I want to put this plot. And then I'm going to plot it. I'm going to plot X and Y. The next argument tells me what color it is. And then the last argument tells me how wide I want the line to be. Okay. If you omitted these last two, then it would just use some default values. Next, I'm going to add a title to it. So in this case, it's a sine wave. So I call it something descriptive like sine wave. Then I do an X label, which in this case would be time. A Y label, which would be amplitude, right? And if we had units, then we should put units in parentheses here too. And then finally, this last command just makes the axes kind of crunch down on the figure so that it doesn't, the scale of the axes is appropriate for this particular plot. So when we run it, as expected, we see a sine wave. Nobody's surprised by this, right? Okay. So then just to demonstrate our point here, if we go to our parameters file and let's say, okay, we tested that with the default parameters. Now we want to change them. Let's say part of our homework is to test it with a different frequency. So let's add in another frequency on a favorite number, somebody. 8. Okay. So everybody should have an idea in their head of what this is going to look like. Okay, I'm going to come back to my main file. Now I could go through and run each section individually, but I know I want to run the whole file. So I'm just going to hit the big play button. Okay, so it's going to take a second. It's going to print everything. And look, there we go. Got our sine wave with a frequency of 8. Okay, does anybody have any questions about this? Okay.
In your main file, reran the parameters, and that's why the update 8 came into this main file. Right?
Yep. So we reran parameters and it overwrote the 8. But we also, another thing we did is we cleared all the variables to begin with, right? And then we reran the parameters, it pulled in the new value, and then ran it from there. Okay. So this structure of having a parameter script and a main script is what you're going to do both in your minor project next week and in your major project, like towards the end of the semester. Okay, you're going to be having a whole set of values, and then you're going to be pulling in those values and then applying. So if you get any kind of errors, like for example, you might get an error of, let's say I wanted to add something in my simulation. I wanted to add an offset, right? So it's that offset. Okay, now if I tried to run this whole script, there'd be an error. There's no variable named offset, right? And it tells me what line it's happening on. The reason is that I haven't defined it anywhere, right? So I need to come back over to my parameter values and I say offset equals 2, for example. Okay, so then we're going to hit save just to make sure everything's all updated. Then we're going to hit run and everything should work. And we can see now that instead of being centered at 0, it's centered at 2. Okay, I know this is a very simple example, but hopefully you can just use the same structure and the same ideas and principles for both of your projects. You will run into questions, I'm sure, and that's okay. I would try asking each other and asking Google and then also asking us and going to Rob's office hours and all that other good stuff. Something to reiterate, just as an organization note, next week, we will not be having discussion sections either. But Michael, the TA, will be holding office hours during the regularly scheduled class time in this room on Monday, Wednesday, Friday. And I encourage you to all try to come to at least one of those to work on the homework and have Michael available to ask questions. He has the fully completed version. He's also very good at MATLAB and coding in general, right? So he'll be able to answer any of your questions. And it'll also be a nice time for you to just, knock it out, get it done. Okay. Any other questions? Lindsay, am I missing anything? Oh, go over publishing? I'm going to have you do that. I don't ever publish.
So there's, for both of your homework assignments, you're going to have to publish your MATLAB script in order to turn it in. Publishing does not mean let's take a picture with our phone of our screen. You would think that that sounds stupid and why not just take a screenshot, but believe me, we've seen some stupid things. So you're going to want to go up into, so there's a button tab right here called publish. And then there's a drop down. So if you click on here and you can edit your publishing options, it's going to tell you this output file format, and it's going to have HTML as a default, but you want to switch it to a PDF as that's what you need to submit to Gradescope. You'll press this little publish button right here, and then it'll take a second, but it'll essentially create a PDF with your script as well as any outputs of your script. It takes a minute. So then you'll see it pops up a PDF of all the things. So, and it also kind of organizes it by the sections that Jake showed you with the double parentheses. And it'll also have your plot. This is how we want you to submit it. You can also, when you have multiple MATLAB assignments, you're gonna have to publish each one separately. So if you notice the parameter file isn't anywhere in here, so you'll have to publish the parameter file separate and then combine your PDFs. Does that make sense to everybody? Okay, if it doesn't, send us a message on Canvas if you have a hard time. Otherwise, your graders are gonna be upset.
I'm gonna start early. Right. Is that all? I think I did everything. Okay,